Hello, you are welcome to my channel. Our topic today is moment of a force. Moment of a force describes the turning effect of a force about a point or pivot. In our everyday life, we experience moment of force in many activities, such as opening a door, turning a water tap, tightening or loosening a knot with a spanner, and riding a bicycle by pedaling with the feet. In all these examples, two important factors determine the turning effect produced. First, the magnitude of the applied force. Second, the distance of the line of action of the force from the axis or fulcrum about which turning takes place. A large turning effect can be produced by applying a small force at a large distance from the pivot. This explains why it is easier to loosen a tight knot using a long spanner than a short one. The longer spanner increases the distance from the pivot, thereby increasing the turning effect. Experienced mechanics are aware that long spanner must be used with care because applying a very large turning effect may damage or strip the nut or bolt. The moment of a force about a point is defined as the product of the force and the perpendicular distance of its line of action from that point. Moment of a force is also known as torque. The SI unit of moment is Newton meter. Moment is a vector quantity possessing both magnitude and direction. When the force acts perpendicular to the object, moment m is equal to force times perpendicular distance. That is, m is equal to F times d. If the force is applied at an angle theta to the horizontal, m is equal to F times d sine theta. Let's take an example. A force of 20 Newton is applied perpendicular to a spanner at a distance of 30 cm from the knot. Calculate the moment of the force about the knot. F is equal to 20 Newton. D is equal to 30 cm, which is equal to 0.3 meters, the SI unit. M is equal to F times D. Substituting, M is equal to 20 times 0.3, which is equal to 6 Newton meter. Example 2. A force of 50 Newton is applied at an angle of 30 degrees to a spanner of length 40 cm. Calculate the moment of the force about the knot. Here, F is equal to 50 Newton and D is equal to 40 cm, which is equal to 0.4 meters. M is equal to F times D sine theta. M is equal to 50 times 0.4 times sine 30 degrees. M is equal to 50 times 0.4 times 0.5. M is equal to 10 Newton meter. So remember, the turning effect of a force depends not only on how strong the force is, but also how far from the pivot it is applied and the angle at which it acts. Understanding moment of force helps us explain many everyday mechanical action around us. Next, we are going to learn about the condition of a body to be in equilibrium. Now, let's begin. A body is acted upon by several forces. It's said to be in equilibrium if it does not move and does not rotate. In other words, the body remains completely at rest. For a body to be in equilibrium, two conditions must be satisfied. First condition, the sum of the clockwise moment about any point must be equal to the sum of the anticlockwise moment about the same point. Another way of saying this is the algebraic sum of the moment of all the forces about any point must be zero. This condition is known as principle of moment. Before we go further, let's quickly understand what clockwise and anticlockwise mean. If you look at a clock, the direction in which the hand moves is called clockwise. Any movement in the opposite direction is called anticlockwise. Now let's apply this idea to a real physics example. Imagine a meter rule pivoted at a point, maybe on a knife edge. When the forces are applied at different points on the meter rule, each force tries to rotate the rule either clockwise or anticlockwise about the pivot. Let's say three forces are acting on the meter rule, F1, F2, and F3. From the diagram, force F1 tends to rotate the meter rule in the anticlockwise direction. Force F2 tends to rotate the meter rule in the clockwise direction. Force F3 tends to rotate the meter rule in the clockwise direction also. According to the principle of moment, since the meter rule is in equilibrium, the total clockwise turning effect must be equal to the total anticlockwise turning effect. So mathematically, we write F2 times D2 plus F3 times D3 is equal to F1 times D1. Here, D1, D2, and D3 are the perpendicular distances of the forces from the pivot. Now, let's talk about the second condition for equilibrium. For a body to completely be in equilibrium, not only must the moment balance, but the forces must also balance. This means that the sum of the forces acting in one direction must be equal to the sum of the forces acting in the opposite direction. In other words, total upward force must be equal to total downward force. From our diagram, forces F1 and F2 are the downward forces, and F3 is the upward force. Therefore, total upward force is equal to total downward force, which is F3 is equal to F1 plus F2. When both conditions are satisfied, the object will neither rotate nor move. Let's take an example. A uniform meter rule is balanced on a fulcrum placed at the 35 cm mark by suspending a mass of 120 grams at the 10 cm mark. Calculate the mass of the meter rule. When solving problems involving moments, the first step is always to draw a neat sketch or diagram. Meter rule on a fulcrum. O placed at the 35 cm mark, suspending a mass of 120 grams at the 10 cm mark. Because the meter rule is balanced, it means it is in equilibrium. Taking moment about O, sum of clockwise moment is equal to sum of anticlockwise moment. This rule is the key to solving the problem. Identify all the forces acting on the rule. 1. The 120 mass hanging at the 10 cm mark. 2. The weight of the meter rule itself. Since the meter rule is uniform, its weight acts at its center, which is the 50 cm mark. The fulcrum is at 35 cm, so we calculate distances from this point. Distance of 120 gram mass from the fulcrum, 35 minus 10, will be equal to 25 centimeter. This mass produces an anticlockwise moment. Distance of the meter rule weight from the fulcrum, 50 minus 35, is equal to 15 centimeter. This produces a clockwise moment. Now we equate anticlockwise and clockwise moments. Anticlockwise moment is equal to clockwise moment. 120 times 25 is equal to m times 15, where m is the mass of the meter rule. 3000 is equal to 15 m. M is equal to 3000 divided by 15. M is equal to 200 grams. The mass of the meter rule is 200 grams. If you have gained more clarity in this lesson, like and share with your classmates. Also subscribe for more physics tutorial. See you in the next lesson.